Hello, my name is Bruce Berriman. I'm the NASA representative on the IVOA Executive Committee, and I'm the chair of the Division B Functional Working Group on the Virtual Observatory. The IVOA delivers standards and protocols on which the VO is built, and it's been a supporter of open science since its inception. UNESCO's recommendations on open science are a good place to start learning about open science itself. The left chart, which is from that document, summarizes the characteristic features of and benefits of open science. Through its protocols, now adopted internationally by data centers and archives to make data accessible through common interfaces, the VO directly impacts open science infrastructures, open source software, and open data, as shown in the red boxes in the chart on the right-hand side. Now, this has already been presented and discussed elsewhere, so I want to talk about another topic that's very fashionable and the subject of immense effort worldwide across many disciplines, and that is FAIR principles. Now, I know openness and fairness are often conflated, but they are quite different things. Open is about data rights and licensing. You're given the data, and the licensing tells you what you are permitted to do with the data. FAIR is all about mechanics. It's about machine discovery and access to data. And it recognizes that data are diverse and that they're scattered everywhere across cyberspace. So what is FAIR? Well, it stands for findable, accessible, interoperable, and reusable. It's a set of 15 principles to support machine access to data. I tabulate them here on this slide. The list taken from the GoFair webpage and itself taken from the original paper by Wilkinson et al. I'm not going to read all 15 principles. I suspect a number of you know them by heart already, but note how often data and metadata appear. You can see that from the italicized bolding I've added to the table. So FAIR principles to a large extent are all about metadata, which is IVOA's stock in trade, right? The protocols we've developed so far are all about a common approach to metadata, and that is in essence why we're developing a FAIR framework. It's one of 3 key items in a vision for the future, as shown in this chart here from Christoph Arveset. Now, the 3 items are all related. The development of a FAIR framework, developed as part of a worldwide collaboration among archives and data centers, will lead to a sustainable open architecture that will lead to exciting new multi-data set, multi-wavelength science. Implementing IVOA standards goes a long way towards implementing FAIR standards. I recommend a talk on this topic by Simon O'Toole, which was made at A-30 in 2021. You can watch it on YouTube. You can also read the paper in the conference proceedings. The next 2 charts will show you where we're compliant. There are a number of principles that are really out of scope for the BO. They're best left to the service provider and others that are really incomplete. For instance, 1.2 metadata associated with a detailed provenance. And you can see how this compliance comes about if you look at a schematic of the infrastructure of the architecture of the VO that's been built up over many years. The 4 pillars of FAIR principles each have an analog in the IVOA architecture. A registry, which is sort of a yellow pages for astronomy, enables finding and discovery of data. Getting is the equivalent of accessibility through the protocols. Sharing is the equivalent of interoperability among different data sets, different archives. And finally, using at the top is the equivalent of interoperability. All right, so I've mentioned that IVOA standards do go a long way towards compliance. How do individual data sets stack up in all of this? So here's a list of Australian data centers from Simon's talk. Simon's an Aussie, that's why it emphasizes the Australian data sets. It's a bit out of date, but it is nevertheless instructive. You can see that a good number are compliant. The red boxes indicate where they're partial compliant. Now, FAIR is actually a continuum. It's not a binary yes or no. So there's a wide spectrum of compliance with FAIR principles, and you see that here. So wonderful. All astronomers have to do is implement VO protocols. We're done. We all sing Kumbaya around the campfire. No, there is a long way to go yet. And the work I'm going to describe in the following slides, this represents a snapshot of the work that we're starting to do and is now underway. And note that what I'm about to describe is actually true of all disciplines to one degree or another. And first of all, there's no validation that we do of these principles. There are efforts underway to develop a validator. Our colleagues in France are studying, for example, the applicability to astronomy of a validator originally developed by the French bioinformatics community. Another group in France is actually studying the fairness of the virtual atomic and molecular data center. So this is work in progress right now, and other fields, of course, are also developing and addressing this topic of validation. Now, another concern lies in persistent identifiers, a long-lasting reference to data. But there's more to identifiers than just the reference. They need to be unique, obviously, and persistent, but they also have to be machine resolvable and processable, and that means they have to have an associated metadata schema. Now, the US government definition I put on the right-hand side takes account of that requirement to have metadata schema. It's not necessarily a better or more rigorous definition than any other. It's simply the one I'm familiar with. All agencies have a definition that is broadly similar to this. Now, metadata is right up the IVOA's alley. And we're working on our schema for astronomy because of parallels of DOI metadata and registry metadata. And you can see that here. That's a summary of metadata from the registry on the left and DOI metadata on the right. I wouldn't try reading all that dense information, but you can see from the labeling that there's a direct correlation between the various classes of metadata. Fairness is a worldwide effort. Want to work with and learn from other disciplines. Deborah Elmer-Green asked me to be the IAU representative to the Co-Data Committee on Fair Standards. I attended a VideoCon in June that was attended by representatives of many disciplines. A lot of common frustrations were expressed by these organizations and disciplines. What exactly do all these FAIR principles really mean? Is there tooling available? How is FAIR compliance going to be funded? So this is a worldwide issue which we all want to work on. So I think we're going to have to do it by working together on these community standards. Now, one example is Ontoportal, which aims to develop a framework for ontology management. Now, a number of disciplines have already signed on to this and are working within it already, and you can see a list of those in the chart on the right-hand side, which is taken from the Ontoportal website. Astronomy is working on a prototype of this with our colleagues at the Observatory in Paris, in France. All IVOA vocabularies have been imported, although not always successfully, and the scope of the work is pretty broad. We're including astronomy, planetary science, heliophysics, particle physics, and atomic and molecular data. So with the next, well, obviously we want to continue to promote FAIR principles in the IVOA in astronomy, continue with the FAIR development work that I've summarized in the previous few slides. Definitely engage with other communities, share war stories and best practices, share and adapt tooling and validators. A number of disciplines have in fact already developed validators that we can maybe take advantage of. I showed one example earlier. In the end, of course, we hope that all of this will lead to exciting new science that we can't do now, and I hope I can come back in 2 years and describe some of that for you. Thank you very much.